Quito is a quantum software testing tool, which can automatically generate test suites according to 3 coverage criteria defined on inputs and outputs of a quantum program. Quito also implements to test oracles based on program specification to assess the program. Quito has 3 coverage criterion, which are input coverage, and input-output coverage. Quito has 2 test oracles. One is WOO, which checks whether a quantum produced a wrong output. The other one is OPO, which a probabilistic test oracle with statistical tests. A user needs to provide the quantum program, the number of total qubits, ID of input and output qubits, and the program specification optionally as inputs. Then the user chooses the coverage criterion. The user can also provide some other parameters such as budget, significance level, and so on. Quito generates test suites using one of 3 coverage criteria. It stops when it generates a wrong output, which fails for WOO. If there is no wrong outputs, and the user provides the program specification, Quito assesses oracle OPO with statistical tests. After the whole process, the user can get the generated inputs, test execution results, and test assessment results. We use command lines to run Quito. We have 3 choices. If we choose one, we can see the template of the configuration file, which is an initialization file. In this file, we can see some of the options are required while other options are optional, as we can use the default values provided by Quito. If we choose 2, we can check one example of the configuration file to help users understand the format of this initialization file. If we choose 3, Quito will guide us to type in the root of the configuration file. Here is the file that we use. We can see the percentage of the test suites generated according to the progress bar. When it finishes the generation, we can see the results in the folder of the quantum program. We can see the inputs, input-output pairs, time of execution, the total number of test cases, and assessment results in separate files. Also, we can see the total run time and the execution time of the quantum program in the terminal. There are some points users need to check. The quantum program file should be written in this way. First, the running method should be named as run with one parameter as the quantum circuit. Second, you don't need to register the qubits and classical bits for your program. Third, you need to measure your quantum circuit to read the output. Also, Quito will check the configuration file. If there is anything wrong with it, Quito will send the error message. For example, for output coverage, if the budget that user sets is smaller than the number of inputs, Quito will show you this error. For a full program specification, if the total probability for any valid input is not 1, Quito will show you this error. Now let's talk about the test coverage criteria. If we provide the full program specification, for input coverage, each valid input should be observed in each test suite. For output coverage, each valid output should be observed in each test suite. For input-output coverage, each input-output pair shown in the program specification should be observed. However, if Quito cannot observe all the valid output, or input-output pair for output coverage, and input-output coverage, Quito stops at the budget. If we provide the partial program specification, for input coverage, each possible input should be observed in each test suite according to the input qubit ID, as we don't know all the valid inputs. For output coverage, each possible output should be observed according to the output qubit ID. For input-output coverage, each possible input-output pair should be observed. For assessment, we only assess the input-output pair shown in the program specification. If there is no program specification, Quito generates test cases in the same way of partial. However, Quito doesn't assess the results. Now let's check the quantum programs with mutants. If we provide the program specification for Quito, Quito will assess the results according to Oracle WOO and NPO. If we run the program with mutant 1 with a full program specification and input coverage criterion, we can get these assessment results. Also, if we run with mutant 2, it stops generating when there is a wrong output. We can get these assessment results.